Okay, so picture this. It's, I don't know, a Tuesday evening. You're at the grocery store. You're in line. It's been a long day. You just want to get home. You've got your stuff on the built milk, bread, maybe a frozen pizza because, it's one of those nights. You get to the terminal, tap your card, you hear that little beep, and you're out. Or maybe you're at an ATM. You put in your PIN, cash comes out. It feels so seamless, so instant. And because the screen looks modern, Face ID and all that, we just assume the tech behind it is, well, cutting edge, brand new code.
That's the assumption, right? We see the shiny front end, the app, and think the whole thing is new. We confuse the system of engagement with the system of record.
Exactly. And that's what just completely blew my mind digging into the reports for today.
Yeah.
Because that engine, the actual code moving your money while you're standing there with your pizza, it wasn't written last year, probably wasn't even written in this century.
No. There's a very strong chance the logic for that transaction was built on a foundation laid back in 1959.
1959. I mean, let's just let that sink in. That's before the Beatles, before the moon landing, before the internet was even a concept. And yet, based on all this material we're looking at, especially around this Pacta Cobol thing, this language is not just surviving, it's running everything.
It really is. We're talking about Cobol.
Cobol.
Common business-oriented language.
It sounds like something from a spy movie.
Yeah.
But, okay, so our mission for this deep dive is to figure out why. Why is a programming language that's old enough to collect a pension still the boss?
Yeah.
Is it just laziness or banks just not updating their systems?
No, definitely not laziness. That's probably the first myth we have to bust. The tools, I really frame this as a story about the invisible pillar of our whole financial world. And for you listening, it's about this looming crisis that's creating a huge kind of hidden opportunity.
Okay, invisible pillar. I like that. But let's get into the scale. How big are we talking? Are we exaggerating when we say it's running the economy?
Not at all. If anything, we might be understating it. Let's just go back to your ATM example. The data we have says that something like 95% of all ATM transactions rely on Cobol code.
95%. So almost every single time I get cash out of a machine anywhere in the world, I'm basically shaking hands with code from the Eisenhower administration.
Essentially, yes. And it's not just ATMs. It's about 80% of all personal banking transactions. Your direct deposit, wire transfers, all of it goes through Cobol, that slick banking app on your phone. It's really just a messenger. It sends a request down a long, long pipe, and at the bottom is a mainframe running Cobol.
So the app is the waiter, but the chef in the kitchen is still Cobol.
That's a perfect analogy.
Yeah.
And because it's been the chef for 60-plus years, the amount of code it's staggering. The estimates are over 800 billion lines of active Cobol code out there.
800 billion.
Oh,
That number doesn't even feel real. How do you even visualize that? A modern iPhone app is, what, a few 100,000 lines? An entire operating system is maybe 50 million? 800 billion is a whole other universe?
Yeah, it is. And here's the part from the reports that really makes you stop and think. It usually surprises people. That number, it's growing.
Wait, what? Hold on. That makes no sense. I would assume it's shrinking. With digital transformation, everyone moving to the cloud, rewriting things. You're telling me we're adding more Cobol.
We are. The volume of code is going up. And it's not just finance. It's insurance, healthcare, public administration, telecoms, basically any industry that relies on mainframes. They're all extending these systems.
So if Cobol just vanished tomorrow, if there was a magic delete button, it's not just that I couldn't buy my pizza.
Oh, it would be a complete catastrophic halt. Insurance claims stop, government checks stop, global supply chains would just freeze. It is the central nervous system of the whole administrative world.
That's terrifying. It really is. But I have to be the skeptic here, and I'm sure people listening are thinking this too. We have amazing new languages. Python, Rust, Go. Why hasn't Cobol been replaced? Is it just too hard to get rid of?
That is the common criticism, it's just legacy junk. But the sources really stress that it's still king for a very specific technical reason. It's not just inertia. It all comes down to math, specifically how it handles decimal arithmetic.
Okay, break that down for me. Math is math, isn't it? 2 + 2 is 4, no matter what language you use.
Well, yes and no. This is a little technical, but it's really the core of it. Modern languages like Python use something called floating point arithmetic. It's great for science, for graphics, where you need a huge range of numbers, but a tiny bit of imprecision is okay. If you do a huge financial calculation in Python, you might end up with a microscopic rounding error, like 0.00000001 of a cent.
Which doesn't matter for a video game or a weather model or something.
Exactly, who cares? But if you're a bank doing billions of transactions, Those tiny fractions add up to millions of dollars.
Right. It's the plot of Office Space, the
Right.
rounding error scam.
Precisely. You cannot have rounding errors in finance. COBOL uses what's called fixed point arithmetic. It calculates money like an accountant does, with a pencil and paper. It's accurate to the penny every single time. No approximations.
So it's a specialist. It's not trying to be flashy. It's just designed to count money perfectly.
That's its superpower. That and its ability to do something called batch processing.
Batch processing. I saw that in the notes. What's that in the real world?
Okay, imagine you're a credit card company. At midnight on the last day of the month, you have to calculate interest and fees for, say, 10 million customers. All at once. You can't do it one by one. You need to process a giant batch of data incredibly quickly. COBOL was built from the ground up to do exactly that.
So the argument is that newer isn't always better for this very specific job.
Yep.
It's like, you don't use a sports car to plow a field. You need a tractor. Cobol is the tractor.
It's a great analogy. And on top of that, there's the risk. The sources are really clear on this. Replacing these core systems is seen as just far too costly and way too risky.
That makes total sense. If you're the head of a bank, the last thing you want to do is risk bringing the whole system down just to use some new cool technology.
Of course not. It's the skyscraper analogy. Your bank is a fully occupied skyscraper. You can't just rip out the foundation while people are working inside.
The building collapses.
The building collapses. So instead of replacement, the strategy is modernization. Companies are wrapping the old COBOL core in new layers. They build what are called APIs, digital bridges, that let modern apps talk to the old mainframe.
So the Cobol core stays in the basement doing the heavy lifting, and the cloud connects it to my phone.
Exactly. It's a hybrid model. And that's why the code is growing. They're building on top of it. But this total reliance brings us to a really big problem, a vulnerability that has nothing to do with the code at all.
I think I know where this is going. We have 800 billion lines of code, a system that needs special knowledge. So who's actually doing the work?
And this is where the story shifts from tech to people. The sources call it a generational renewal challenge. To be blunt about it, the experts are all retiring.
The silver tsunami.
Yes. The people who wrote this code in the 70s and 80s who understand its quirks, they're aging out, and they're taking all that knowledge with them.
And I'm guessing universities aren't exactly pumping out 21-year-old COBOL experts. Everyone wants to learn AI or build apps.
Precisely. So you have this huge mismatch. The demand for COBOL skills is stable or even growing, but the supply of talent is just falling off a cliff.
Which, for a bank, that's a crisis. But for anyone listening, that sounds like a huge opportunity.
It's a massive opportunity. The source material is very direct about this. Learning COBOL today is a strategy for maximum employability.
It's a contrarian bet. While everyone is rushing to learn the trendy new thing, this niche is sitting there with tons of open jobs and almost nobody applying.
And incredible job security. Startups have layoffs. Banks and governments that rely on these systems, they're stable. If you're the person who can keep the lights on, you're essential.
Okay, but let's talk about the fear factor, because I think this is what stops people. You hear 1959 and mainframe, and you just picture something ancient and impossible to learn. Do you need a PhD to even understand it?
That's the biggest misconception, but the reality is actually the opposite. The sources point to the original design philosophy of COBOL. The B stands for business.
Common business-oriented language.
Right. It wasn't made for computer scientists, it was made for business people. The syntax was intentionally designed to look like plain English.
You mean like readable sentences?
Yes. A line of code in another language might be all cryptic symbols. In COBOL, it's literally AD salary to income, or perform until end of file.
Add salary to income. That's not code, that's just a sentence.
Exactly. It's wordy, sure, but it's readable. The idea was that anyone could look at it and get the gist. So the real barrier isn't difficulty, it's just perception. People think it's hard because it's old.
They think it's rocket science, but it's actually more like reading a recipe book.
In many ways, yeah. And that brings us to the specific solution in our source material, the Pacta Cobol initiative.
Right, this is the training program designed to tackle the shortage.
It is. The text describes it as a gateway to democratize access to these mainframe jobs. They're trying to break down that gatekeeper mentality.
Democratize, so making it accessible for people who aren't already tech insiders.
Correct. The source says their training is for total beginners. No heavy computing background needed. You don't have to be some kind of math genius.
That's huge, because so many coding boot camps say, beginners welcome, but then you're lost in week one if you don't already have some background.
This seems different. It's online, it's flexible, so people can learn at their own pace. You could do it while you're still at your current job. You don't have to quit your life to learn a new skill.
And what about how they teach? Is it just reading dusty old manuals?
No, and that's a key point in the source. The approach is practice over theory. It says learners are manipulating syntax as it's really used today in a professional environment.
That's important. It's vocational. It's teaching you how to fix the bug the bank is actually paying you to fix.
Exactly. It's the difference between studying engine physics and learning how to be a mechanic. Pacta Cobol is training mechanics.
And the notes also mentioned another barrier cost.
Yes, a 4-year degree is a massive investment. Boot camps can be thousands and thousands of dollars. The source describes this path as an affordable investment.
Which makes sense. If the industry is that desperate for people, you shouldn't be charging a fortune to let them in. You should be making it as easy as possible.
Exactly. It's not just about selling a course. Initiatives like this are trying to solve a real macroeconomic risk. They're trying to make sure these essential systems keep running.
It totally reframes the idea of a tech career. We always think it's about inventing the future,
Hmm,
but there's just as much value in sustaining the present.
that's a great way to put it. We're all addicted to the new thing, to disruption. But civilization depends on continuity.
Okay, let's zoom out and put a bow on this.
Mm.
We started with tapping a credit card.
And found out the machinery behind it is older than the credit card itself.
We learned that despite all the hype, the bedrock of the economy, 95% of ATM transactions is completely old school, and it's getting bigger, not smaller.
And the guardians of that bedrock are retiring, leaving this huge talent vacuum.
Which brings it back to you, the listener. If you're thinking about a career change or you're just tired of the tech hype cycle where everything changes every 6 months,
Yeah,
this is a very different path.
it really is. It challenges our obsession with new. We tend to undervalue maintenance. But as we've seen, stability is incredibly valuable. Stability pays.
It's like being a restoration expert for a historic building. You know the building isn't going anywhere, and you're one of the only people who knows how to fix the foundation.
That's it, exactly. And learning it isn't a return to the past. It's a strategic investment in your future. You're betting on the house.
So here's the thought we want to leave you with. In a world that's obsessed with the next big thing, are we seriously undervaluing the quiet, critical infrastructure that actually keeps the lights on?
And maybe more urgently, if this talent shortage keeps going, what happens to that ATM transaction 5 years from now? The code will still be there, but will anyone be left who speaks the language?
A pretty scary thought, but also a huge call to action. Thanks for listening to this deep dive, and we'll catch you on the next one.